Hello guys, so in this video I will go through another way to represent data, that is through a histogram. A histogram can be used to represent both continuous and discrete data. However, it is best suited to illustrate continuous data. So if you don't know the difference between continuous and discrete data, then you can go back and check my video on introduction to stem and leaf diagram. I have explained it over there. So what exactly is a histogram? A histogram is a type of a graph which has columns in it. So it is a graph with columns, but these columns should not have gaps between them. So no gaps. I'll tell you what I mean by that. Let me just write a data set down and I'll be back. Okay, so here we have a particular data set where these are our class groups and this is our frequency, and here we have frequency on the y-axis and class groups on the x-axis, right? So in this particular data set, our class groups do not have gaps between them. What I mean by that is our first class group is from 0 to 15 and the next one is from 15 to 30. So if you see over here, we don't have a gap, so no gap, right? So when we make a histogram, there is not gonna be a gap between the two bars, right? Sorry. So let's see. So our first class group is from 0 to 15. So 0 to 15 and our frequency is 6. So our column is going to be something like this. Let me just take a scale out. So there's a line. Oh, sorry. This is our first column from 0 to 15. Oops. And then our second frequency class group is from 15 to 30 with a frequency of 8. So our second column is going to be something like this. 8. And then our column is going to look something like this. Right, and then our third class group is from 30 to 45. Again, you can see that there is no gap over here. So 30 to 45, there's no gap, and then our histogram will have no gap, so it will directly be from 30 to 45. And our frequency is 4, so this, and then a horizontal line over here, right? So there is no gap between the three bars. So our condition of a histogram being a graph which has columns but no gaps between them is fulfilled. But what if our next group is from 45 to 60? So again, there is no gap over here, but the frequency of this 45 to 60 group is 0. So in that case, we won't have to draw a anything over here. So it will be blank over here, right? So let's look at our next group, which is 60 to 75. So let's say our next group is 60 to 75. So again, no gap over here, but it has a frequency of 2. Let's just assume. So 60 to 75, we have a frequency of 2. So our column will look something like this. Now, even though a histogram should not typically have gaps between them, but since this 45 to 60 group did not have a frequency, like its frequency was 0, hence we have a gap over here. This is the only case when a histogram can have a gap. Other than this, a histogram should never ever have a graph between them. So the only time when the histogram can have a gap is when frequency is 0, right? So now we are going to do some past paper questions. Our first question is from May-June 2018, variant 6.2. The question says that the length T minutes of 242 phone calls made by a family over a period of 1 week are summarized in the frequency table below. The length of phone calls, T minutes, are given and then the frequency is given. Find the value of A. So now since there are total of 242 phone calls, then the frequencies must add up to 242, right? So what we'll simply do is we will add all these frequencies. So 14 plus 46 plus 102 plus A plus 40 must be equal to 242, right? So our A will be equal to 40, right? So then the next question is that calculate an estimate of the mean length of the phone calls, right? So to calculate the mean, what we do is we find the midpoint of these lengths. So we will find out the midpoint of 0 to 1. So the midpoint of this will be 0.5, right? So this midpoint will be 0.5. Then we'll find out the midpoint of this. How will you find the midpoint? You will add the upper class boundary, this is the upper class boundary, to the lower class boundary. This is the lower class boundary, and we will divide it by 2. So 1 plus 2 is 3. 3 divided by 2 is 1.5. So our midpoint of this class group will be 1.5. The same will happen here. Lower class boundary 2 plus upper class boundary, which is 5, and we divide the both by 2. So 2 plus 5 is 7. 7 divided by 2 is 3.5. So 3.5 will be this midpoint. We'll do the same here. The midpoint of this will be 5 plus 10 divided by 2. So 15 divided by 2 is 7.5. So the midpoint of this will be 7.5. In the same way, the midpoint of 10 to 30 will be 20, right? So how to calculate the mean? You multiply the midpoints with the frequency and then divide it by the total frequency. What I mean by that is that we multiply the midpoints. So our midpoint is 0.5. So we multiply 0.5 with 14, which is our frequency, and then we add it with the next thing. So our next midpoint is 1.5 with our frequency is 46, right? And then the next. So our next midpoint is 3.5 and our frequency is 102. Then our next midpoint is 7.5 and our frequency is A, and since the value of A is 40, so we multiply this by 40. And then the next midpoint, which is 20, and we multiply it with the frequency, which is 40 again. And then we divide this whole thing by 242, which is our total frequency. So the formula for estimated mean for this grouped data is EFX with EF. So here F is our frequency and X is our midpoint. When you calculate this, you'll get the answer 6.33. Okay, so for the next part, we have to illustrate the data in the form of a histogram. So the thing is that the class intervals for this data set are not equal. What I mean by that is if the class width of this is 1, because 1 minus 0 is 1 and 2 minus 1 is 1 again, but 5 minus 2 is not 1, it's 3, and 10 minus 5 is not 1, it's 5, and 30 minus 10 is 20. So since these are not equal, we'll have to add another column. That column is known as the frequency density column. So the formula for frequency density is frequency over class width. So frequency over class width. So we'll calculate it. So for this first one, so frequency is 14 divided by class width. Class width is 1, so 14 divided by 1 will be 14. Same goes for here. 46 divided by 1 will be 46. 102 divided by 3 is 34. And A is 40. So 40 divided by 5 is 8. And 40 divided by 20 is 2. So this is our frequency density. So here, instead of frequency, we will plot frequency density on the y-axis and the class intervals on the x-axis. So I've labeled the axis, then we will start drawing our histograms. So our first frequency is 14 from 0 to 1. So 14 will be somewhere over here from 0 to 1. So And then we have 46 from 1 to 2, and then 34 from 2 to 5. And then 5 to 10 we have 8, and then 10 to 30 we have 2. So I've plotted all the columns, and this is what our histogram will look like in the end. Now let's move on to the next question. Okay, so our next question is from October-November 2019, variant 6.2. The problem with this type of data set is that, as I mentioned earlier, there should be no gaps between our histograms, right? But here we have a gap between the two. What I mean by that is that our next is not starting from 29, it's starting from 30. So there is a gap of 1. This is not starting from 40, it's starting from 39. So again, we have a gap for 1. So to accommodate this gap of 1, we split that 1 into 2. So 0.5, and then we add 0.5 to the upper boundary, and then subtract it from the lower boundary. So for this particular group, it will be 10 minus 0.5, so 9.5 to 29 plus 0.5 is 29.5. In the same way, 30 to 39 will be 29.5 to 39.5. 40, so 39.5 to 49.5, and then 49.5 to 59.5. And then for 60, it will be 59.5 to 89.5. So now we don't have a gap between the upper boundary of the previous group to the lower boundary of the next group, right? So we don't have a gap between 39.5, 39.5. So now our histogram will be continuous. Now we do the same thing. Since our class widths are not equal, this will be 20. This class width is 20. This class width is 10. This is also 10. This is also 10. But this is 30, right? And then we make a column for frequency density. So frequency density is frequency over class width. So frequency will be 10 divided by 20 for the first group, which is 0.5. For the second group, it will be 24 divided by 24 divided by 10. So this is 2.4. Then we have 30 divided by 10, which is 3. And then we have 14 divided by 10, which is 1.4. And then we have 12 divided by 30, which is 1.2 to 0.4, right? So I have labeled the axis. This is our frequency density on the y-axis and our class groups on the x-axis. So our first frequency density is 0.5 and our class group is 9.5 to 29.5. So 9.5 to 29.5 with 0.5. So 0.5 will be somewhere over here. 0.5 from, okay, so when your class groups do not start from 0, you're supposed to do this triangle thing on the bottom to indicate that our axis is not exactly starting from 0, right? Because normally it's assumed that it's starting from 0. Okay, so our first class group is 0.5 from 9.5 to 29.5. So this will be 29.5, right? And then we draw vertical lines to complete our columns on 9.5 and then on 29.5. So our next class group is from 29.5 to 39.5. So I'll first draw vertical column, up to 2.4, because that's our frequency density for the next column. So 29.5 to 39.5. 2.4, right? And then it's 39.5 to 49.5 for 3. So we will draw vertical columns up to 3 and then a horizontal one, right? So our next one is from 49.5 to 59.5 for 1.4. So we'll draw a vertical line up to 1.4. This is 1.4. Yeah. And then our last column is from 59.5 to 89.5 up to 0.4. So this is what our final histogram will look like. That's it for this video. I hope I was helpful for you guys. See you in the next video. Goodbye.